Hello, sixth period. Sorry I couldn't be with you. I am on a field trip. So what I'm going to do is we're going to review today a little bit about factors and greatest common factor, and then we're going to have notes on factoring algebraic expressions. I don't want you guys to fall behind the other classes, so follow along here. Let's maybe do these on like a separate piece of paper or a whiteboard. It's more kind of like a warm-up review. So a factor is a number that multiplies to make whatever product you're trying to do. For example, 12. What are the factors of 12? One way to do this is, you go 1 and 12. 1 times 12 is 12. It's an even number, so I know 2 goes into it. 2 times 6. 3 goes into 12. 3 times 4. And that's it. Those are the factors. Now, if you have them in that order, it's kind of confusing, so I always recommend putting them in order. So it's 1, 2, 3, 4, 6, and 12. All right, try this one on your own. What are the factors of 100? Pause this video and see if you come up with what I'm about to. All right, so the factors of 100 are going to be 1, 2, 2 times 50, 4 times 25, 5 times 20, 6, no, 7, no, 8, no, 9, no, 10 times 10, so that's a factor. And then you start working backwards, so, it was 5 times 20, 4 times 25, 2 times 50, and then 1 times 100. So 100 has 1, 2, 3, 4, 5, 6, 7, 8, 9 factors. And a factor could only be a whole number. You can't do like a decimal. They want whole numbers. And then another thing you might have learned in 6th grade is greatest common factor. This is the largest factor at least 2 numbers share. So if we're going to find the greatest common factor of 15 and 33, there's 2 ways to do this. One is list all the factors and then compare them and try to find which one, the largest one that matches. So let's start with 15. So we have 1, 3, 5, 15. 33 is going to be 1, 3 times 11, and then 1 times 33. All right, so now looking at these, which number is the largest common factor? I'm looking here. 1 and 1 are common. You're really never going to want to use 1. 3 and 3 are common. 15 has 5, but 33 didn't have 5. 15 doesn't match, 33 won't match. So it looks like the greatest common factor is going to be 3. So that's what that would be. If you have smaller numbers, this strategy is pretty good. If you are doing larger numbers, it could be a little tedious. You might forget factors. There's another way to do it. I call it a factor tree. So the way I do a factor tree is I put one number here, 42, and then the other number will be 68. And then you kind of branch off. Like you could use any factors. Like what are 2 numbers and multiply to get 42? It's even, so I know that 2 times 21 would work, right? It's 2, 21. Now 2 is prime. It can't be broken down. 21 is composite, so I could break 21 down. So what are two numbers that multiply to get 21. Well, that would be 3 and 7. All right, so when I do this for 68, 68 is also an even number, so I know 2 goes into it. So 2 times that 34. Well, 2 is prime. 34 is not. I could break 34 down. 34 is going to be, what was that, 17 times 2. So now looking at it, you want to look at the bottom of your factor tree. So we have 2, 3, and 7. And over here we have 2, 17, and 2. What do they have in common? That would be 2. 2 on each one of these. Do they share anything else? I don't think so, just 1, 2. So the greatest common factor is going to be 2. Here, let's give you one to do. Let's do find the greatest common factor of, let's do 24 and 80. All right, use either strategy. Pause this video, try to see what the greatest common factor you come up with, and then unpause it to check your answer. So I'm going to give you a moment here. Pause it. All right, we're back. So let's see what you got. So 24 and 80. I'm going to do the factor tree real quick. Go back and take this. All right, 24. Then you could use 6 times 4. You could do 2 times 12. It doesn't matter. You're still going to end up with the same answer. So I'm going to go 6 times 4. And then looking at these, neither of these are prime. 6 could be broken down into 2 times 3. And then 4 can be broken down into 2 times 2. So let's do that for 80. 80, I'm thinking 10 times 8, so I'll start with that. Uh, 10 can be broken down into 2 times 5. And then 2 and 5 are both prime, so that part's done. But we still can break down 80. I'm going to do 4 times 2. And then with a 4, I could break that down into 2 times 2. All right, so this one's a little different because now they're going to have more than one number that they share. So looking over here, I see a 2. They share 2. 3, there's no 3s over here. There's another 2. So they're sharing 2 2s. And then, or they have another set of 2s on each one. Well, this one has a 4 2, but this one's out. So when you have more than one number, you want to multiply what they have. So in this case, you'd have 2 times 2 times 2 is going to equal 8. So the greatest common factor is 8. That's what they share. All right, we're going to use this review to do factoring expressions. So this is where you're going to need your notebook. Today's date is going to be That's tomorrow, so it's going to be 2-25. And feel free to pause this anytime to catch up. I just don't want you guys to fall behind the other class. All right, so now I'm looking at 2x plus 18. So when we're factoring an expression, we're almost going to set up a distributive property that is going to equal this. It's like working backwards. Instead of doing the distributive property, we're going to create what expression would equal this using parentheses. And we could check that here in a second. So 2x, that literally means 2 times x, right? Put a dot for multiply. All right, so we have 2 times x, right? And then 18, the factors of 18, maybe I'll do this in a different color, are red. It's going to be, well, I know 2 times 9 is going to equal 18. Okay, so they both have a 2. So you want to identify what is a common factor, and to do it correctly, you should find the greatest common factor. In this case, it's 2. So I'm going to pull these 2 out. Okay. So they share the 2. I'm going to put that 2, and then I'm going to have my parentheses, 2 times, well, what's left? We have x, and then we have a positive 9, plus 9. So we have now factored that expression, 2x, 2 times x plus 9. And if you wanted to check that, you do the distributive property. 2 times x is 2x, 2 times 9 is 18. All right, let's try example 2. Factor the expression 12 plus 32y. So pause this video, try it on your own, and then play it and see if you come up with the same thing. All right, I'm back. I'm thinking the greatest common factor of 12 and 32y is going to be 4, because I know 4 times 3 makes 12, and I know 4 times 8 times y is going to make 32y. So let me put a little multiplication symbol here. Okay, so again, we're looking for what they have in common. So I see 4 and 4. All right, so I'm going to pull that 4 out when I'm writing my equivalent expression. So I'm going to pull the 4 out. I'm going to write it over here, 4, and then you want to use parentheses. Times what? Well, on the first term is 12. So 4 times 3. So the 3 was left over. This next term is a positive 32y. So I'm going to put plus, and then what's left over? 8y. And that is factored. That is the answer. Ms. Garcia, what if I wrote it as 4, times the sum of 8y plus 3? Is that still correct? Yeah, that would still be correct because you would get 32y plus 12, and using the commutative property, you could flip that around, and it's equivalent. So either way would be correct. All right, let's try. We got a couple more examples here. So example 3, again, pause the video. Try factoring 24j minus 16. This one's a little different because you have a subtraction symbol here. All right, so I'm back now. You had a chance to try it on your own. I'm going to say the greatest common factor of 24j and 16 is going to be 8. Because it's 8 times 3 times j. And this would be 8 times 2 to get 16. All right, so we have these, and what do they have in common? Well, they have the 8 and nothing else. So I'm going to pull those out. All right, so 8 times, and then what are you left with? Well, you're left with 3j. Now you want to make negative 16, so you want to have minus 2. And we could check that, if I wanted to use the distributive property, and I do 8 times 3j, and then 8 times negative 2, and I would get 24j minus 16. Look, it matches. Now, some of you might have, factored, and you might have used, 2 or 4. Did you create an equivalent expression? Yeah, so you're not necessarily wrong. So if you did 2, you would end up with 12j minus 8. And if you did 4, if you pulled 4 out, you would add 4 times 6j minus 4. In algebra, you're going to want to pull out the greatest common factor when you're doing problems. But as far as 7th grade goes, all of these are good. This one would be the best, and then these are still good. All right, let's move on. Let's do example 4. All right, pause this video, and this one's a little more complicated, and try to see if you can factor this term. All right, we're back. Let's see what you ended up with. So 14x, 7y, and 21. I know 7 goes into all these, so I'm going to pull the 7 out. Then what am I left with? Well, in the first term, I'll be left with 2x, because 7 times 2x is 14x, plus 7 times y would be 7y, and then 7 times 3 would be 21. All right, so we actually have 3 terms here, so you should have 3 terms within your parentheses. All right, let's check and see if that's, right. 7 times 2x. All right, so we have, we would get 14x plus 7y plus 21 if I was to distribute that. Does that match what we needed it to up top? It sure did. All right, I'm gonna let you guys know that you're gonna have SDL. Try to make sure you get all your checkpoints caught up if you're behind on any. Um, you're gonna have your end of unit assessment the next class period in math. So get ready for that. So make sure you're good at two-step equations and the distributive property, plugging in numbers. There's going to be questions like that on there. If you have any questions or concerns, reach out to me, shoot me an email, and have a good day. Be nice for the stuff